some type of workload in multiple processes, you can do like a multi-processing context, and at the same time when you need to expose just as a one single process, and within that you need to run several threads, like in this case you can expose as multiple threads. So if you ask me, I have written a code which contains multiple processes so that I have the liberty of pushing this code in whichever way I want. I can run this each process in the same computer, or else in the same server, because it's a server code. Or if I want, I can run each process. Let's take an example like this processes, okay, or else let's take an example like this Firefox. So you can see it has several instances running in the system. As you can see, if you open multiple tabs, and for each tab Firefox may open a specific process. So I can architect a server code in a way that I can run each process on a single server if the process is quite resource intensive. Sometimes the processes can be processor intensive, at the same time memory intensive and stuff like that. So if it is choking the server and taking around 90% of its CPU resources, what I can do is I can run these processes in multiple servers. So I have that liberty. You don't have that choice if you do threading all the time. So if you do multi-threading, the problem is you need to fit all these threads within the same process. So now the problem is, if the system is getting choked up, you don't have a liberty of chopping this and then pushing into multiple systems. So this is why I'm saying, you are at the very young age of 2 to 5 years of industry experience. You need to think about the bigger aspect, about the business implications. Sometimes it is meant for a very large high performance computing where you don't need to think like this is also one problem I get. I often get sometimes students from embedded platform. Apart from students who are into academics, and of course I have some in doing their PhDs, and also I have many students who are even elder than me, who is around 40 plus years. Okay, so sometimes they are also even managers, or else even some type of role. But again, they come because they need to get themselves into some type of a CTO role or some type of technical aspect. So not always I may list all these names in my students page, but I do get students in this type of mode. But other than that, as I say always, I do consult many companies, and when I dig down their existing architecture and I propose how I can change and do some modifications to scale this up to the next level. So you need to see these aspects. Please note, when you do a production level software, it is never going to be, suppose if you're even more new to the industry, I'm giving an example. So if you take this type of sample code, by no means your production code will be so tiny like this. So don't get fooled by thinking or reading these aspects and then try yourself comparing with a real production code. See, the production code may have 30 to 100 threads, or it may even have 200 to 300 threads, or even more. Okay, I'm saying process threads. Okay, threads within a process. So it may have any number of threads. Okay, there is no limit. And so when it it has a chance of getting so many threads, and in case if it is quite CPU intensive or something, then here is a situation. If there is a situation that all these threads are quite similar and they are quite doing the same job, let's assume each one is picking a file or some packet, it is compressing and it is giving some kind of an output or something like that. It is just doing a repetitive job, or it may be a VPN server. It is taking a packet, encrypting and sending it out. Or else, if you think in the case of Toffee or my earlier Trophy Squeezer, it takes each packet and then process these packets and it optimizes in several layers. So it's just like a batch mode operation. It does some processing and then it sends it out. Okay. So such type of repetitive workload, what happens is you may have an option to do in many processes as possible. Okay, so you can spawn as many processes as possible, so you have such liberty or option, or else you can put them into any number of threads as well. So the problem is, if you have just a single process and then you have so many threads working within the same, if some thread is crashed or something happens, what happens is it is going to corrupt the entire, it is going to kill the entire process. Okay, so naturally what happens is the entire job will stop. So this is what I have discussed about the process versus thread in the systems architecture perspective. So this is one aspect. The other aspect is, as I said in this episode, if there is a process and it is consuming a lot of CPU and it is quite CPU intensive, now what happens is it is going to choke the entire system resource. So this is the thing. To cope up, what you can do is you can split this into multiple processes, and then you can pick instead of one server or a VM host or whatever, instead of one device, you can spread this across multiple devices. Please note, again I'm saying, see, this is not something, a code what you see in this hello world kind of internet examples or your college books. I'm saying this is a full-fledged code which has thousands of things it may do. It may have several features and it may be quite resource hungry. So in that case, what happens is you can spread this across multiple servers. So each server can have very good config. Okay, so it may be even some servers can have even quad CPU. So it may have around 60 CPU cores or whatever it is. Let's assume it has a quad CPU chassis and motherboard and things like that. So if you are still new to that, because again I see developers lack this real world exposure, so you can go to Supermicro website, Supermicro server. You can go to the Supermicro website and you can go through some of their hardware. You can go through and you can check, you can select what type of hardware you want to learn, or in case if you are going to buy for your company as well, of course you can go through the same. And this is something often I consult with my clients, because sometimes they want to put across a particular hardware for a specific workload, and I do a lot of that initial analysis, and then I give my opinion to them. And of course they do pay for this kind of a job, because the server is not cheap. They invest a lot of money and they may need several of them. So sometimes they need to consult. It's just asking some network admin will not do the job. Okay, so it needs a system level analysis. So that's what you can see here. You have various types of servers. Some motherboards, you can see you may have a dual chassis motherboards. As you go higher level, okay, some may have dual CPU motherboards and stuff like that. Okay, yeah, so this is a single CPU. Let's go to a bit higher end, and in that case you may even find super workstation. Let us search as super server. Yeah, these are like high-end, high config servers. If you explore here, sometimes you may see 2U rack mount, socket, dual socket, and let us see if anything has a dual socket. Yeah, this looks like a dual socket. Yeah, this is, as you can see here, this has a dual socket CPU motherboard. So each CPU is taking up to 12 DIMM slots, so which is around 24 slots or something the overall the motherboard have. So this type of setup I am talking about. So here when you talk about process and threading, this is not some college basics is going to help you, nor some type of hello world examples is going to help you, which you will find in the internet. Okay, so sample socket, or I'm sorry, sample multi processing code in C. Let's take an example in C. So you may find some few examples here and there. What is that they are trying to teach here is just a single example. It's a very simple basic, and they are just giving some example. Just imagine, in a real production system, the same code have to spawn around 1000 processes. Okay, so how do you keep track of 1000 processes? Sometimes there is a subtle difference between different processes. How do you keep track of them? Okay, so this is the big challenge. Okay, so what you see as a sample code is just a hello world code. It doesn't do anything useful, to be frank. It only teaches the overall idea about it, so that you can start using this platform, and then you can start take this snippet and then build your actual application. I mean to say, even kernel module, anything. I mean to say application means what is the requirement is you are supposed to achieve. Okay, so you can take this type of a snippet and you can do your application. Same way you can do multi-threading, and again, as I showed of the multi-threading also, you will get some type of example in the internet. So let's take example like threading. Yeah, you will get lots and lots of sample code, but if you see the real case, you can see a lot of documentation. You can find this type of cool examples you can find. The problem is often this is just a beginning point, so that you get that code snippet, but the production code is going to be completely different. It will have a lot of other aspects. It's not, the code is not going to only have this multi-threading just about it. The code will have various other important modules. In case if the modules have to communicate, it may have some type of API to API flow. Sometimes they may write different layers of API. Sometimes you may have some helper API. Sometimes you may have common APIs. And suppose if you use any lists or linked lists or tree or some type of data structure, you may have some common libraries which may be an IP for that company. I mean to say intellectual property for that company. You may just include that same files over and over again for various other projects as well. So all this type of things will involve in a real production code. So don't ever confuse if you're less than even that 1 year experience, and if you're or else if you have not worked in a real production code, don't get into an assumption. Seeing some example like this, you are ready to scale this up into something big. It is not. The code is not about you will never get a requirement saying that, hey, you need to do this code with multi-threading. No one will give you a job like this. Okay, don't get into this confusion, because I do sometimes get queries like that, or else even my own students ask questions like that. Okay, so you will never get any requirement like that. It will be completely something which fits to the real world use case, which is not going to be something like what is your questions you get in your school or college. Okay, in the college they may ask write a sample C code to do some linked list or some binary tree or something like that, but in the real world it is completely different. So I'm giving an overall perspective. It depends on what you want to achieve. When it comes to threading and processing, there are so many, multiprocessing, there are so many aspects are involved like this. Some I have discussed in a couple of episodes, what I showed earlier, which perhaps even those 2 video links I'm going to attach in this YouTube description, so that you can watch them again to get some big picture. So in case if you have any questions related to systems architecture or anything basic to advanced topics, be in touch via mail or send your queries in YouTube comments. If the query is quite complicated to answer in YouTube comment, maybe I may suggest to get back in the email, so that we can discuss more. Or else if you are interested in terms of taking any classes or courses or something, you can anyway think about it, in case if you feel you need to learn a lot rather than just getting answers for this query alone. Okay, so be in touch via mail or YouTube comments. Thanks a lot for joining me. Stay tuned. Have a nice day. Bye bye.